مرحبا مرحبا، كيف حالكم؟ شو الأخبار؟ تمام إن شاء الله. هلا الميكانيكس زي ما إحنا شفنا، زي ما حكيت لكم في البداية، الميكانيكس it's a mathematical analysis for the motion of particles. So it's not physical point of view, it's mathematical point of view, not physical. So we will always think with math while we are doing questions, not physics. Okay. Now, kinematic of a particle moving in a straight line, you can use formulas for constant acceleration to model an object moving vertically in a straight line under the influence of gravity. As I told you before, we have certain kind of templates, or we can say samples. So as we have said before, the particle could move if this is the ground level. The particle could move upwards and then downwards. Okay. Now at this point, there is the projection speed, which is initial speed. That's u. So we have a u. Then when it goes up, because it is against gravity, we say that the acceleration is negative 9.8, as we have said last time. Then at this position, the particle will stop for a moment. So I will say that v, final velocity for going up trip, v is equal to 0. Now, when it's coming down, this is the second part of the journey, which is coming down. I will say that our u is equal to 0, which is initial. Then the acceleration is equal to 9.8. Then when it comes down, the velocity, there is a value for the velocity. There is a velocity in the before it hits the ground. So this is the first scenario, okay? And there is something important in this scenario, which is when the particle hits the ground, the displacement is equal to 0 because this is your starting point. It went up and it went back to the same point. So displacement. لكن مرات في الأسئلة they will say find the distance traveled, means the whole distance traveling for this particle in space. Now, scenario number 2, when the particle free fall from somewhere. For example, a ball. We have a ball on a shelf, and this ball falls under gravity. Free fall, بنسميها. So the acceleration is 9.8, and the u, because it was in a position that it was on the shelf, the u was a 0, and in the end we have a v. There is a velocity before it hits the ground. In this case, the displacement is equal to distance traveled. Okay. Now, if this third scenario that we will talk about, if we have a particle here and this particle was projected upwards, then it comes down. Okay. So in this scenario, there is a u, the initial speed, where is the particle projected upwards. So when it's going upwards, a equals negative 9.8. And at this point, we have a v equals 0. And then it's coming down, so the a is equal to 9.8. And at this stage, at this point, the s is equal to 0 displacement. Then the s starts to be a negative below the projection level. And there is, in the end, we have another v, which has a value if we consider there is a u is equal to 0 at this point. Now, those three scenarios, let's come back to the slide and let's see the questions that we talked about. Now, where is yeah. Okay, so we have here the gravity causes object to fall to earth, probably already known, acceleration, the means of acceleration, earth, and all of those things that we will see in the questions. We have those for 5 Savat equations. This is the first, second, third, and fourth, and fifth. In the first, there is the letter S, as you know. It's not there. In the acceleration is not there. V is not there. T is not there, and there is a U is not there. So it depends about what is not given in the question. We can choose the suitable rule. Now a ball is projected vertically upwards from a point O with a speed 12. So أول إشي كيف نفكر في السؤال. That is your U and projected vertically upwards. So the journey is similar to that. Ground level. Point O as a speed. So the U is equal 12. You have to do your mathematical analysis. They will not tell you about the acceleration. 9.8, هنا V equals 0, هنا A equals 9.8. They will not tell you about everything in those details. You have to know it yourself. Find the greatest height reached by the ball. The greatest height means the distance traveled out the displacement when U equals 12 up to V equals 0, acceleration. So we have 3 letters, 1, 2, 3, and they need the displacement. So the time is not there, so we will choose the equation without time. This is your equation. Okay, let's see the solution. So that's 12, and then the highest point, first of all, we have to write down what is given, what is missing, what is not wanted. Then we can choose the suitable equation without t, substitute, find the value of s, so s equals 7.4. Then the total time taken, now everything is clear for you. All information are given. All you need to do is to choose the suitable equation. Okay. Now, block is falling. That's a free fall. I think we have stopped over here last time. Free fall means U equals 0 because top shelf falls off the top of the shelf. The shelf is 1.4. It appears that there is a U equals 0. That's the distance of displacement because the displacement is equal to the distance. Above ground means that there is an acceleration. A equals 9.8 and there is a V over here. Find the time taken. We need the time. We have S, we have U, we have A. We can find the time. We choose equation without V. We may use this equation without V, or we may use this equation. No, we may use, yes, this equation. So this is the scenario. Let's continue. That's T, then we can find T. Of course, square root negative number is not accepted. Then we can find the V by using any equation of those 5 equations. A ball is projected upwards from point X, which is 7 meters above the ground. So this is the case of the scenario number 3, just like that. Okay, there is a U, there is acceleration, there is a V equals 0, there is an acceleration also up to this level. We have S equals 0. That template for such kind of question. Initial speed is 21, time of flight of the ball. من هون ل the other side تحت هون بده V. بدوش V, بده time up to before it hits the ground. So that's the scenario that we're talking about. There's no V. We may find the time in this way. So we have time 2 times. We'll get 2 times. That is, So that's a 4.6. Of course, the time is not negative. Particle projected vertically upwards from a point O with initial speed u above the ground. So that's a ground level. That's a ground level question scenario. Find the speed of the projection, means u is unknown. So vertically upwards means there is an A equals negative 9.8, there is a V equals 0, there is an A equals 9.8, and it reached by the particle as the greatest height. We have the greatest height, which is the distance traveled 6.62.5. So that's the S. So we have A, we have V, we have S. We need to find U. So, and then that's a U. So we'll choose an equation without time t. That is your equation. So then U equals 35. Then they are talking about the total time for which the ball is 50 meters or above the ground. Now let's math, do the job. The total time for which the ball is 50 meters or more above the ground. We are talking about displacement S. That is a displacement S. Okay? And in this displacement, we have a quadratic equation. We need the ball above the ground 50 meters. Let's say that's a 50 meters. That's a 50 meters above the ground. Means what? Means the total time taken, the time taken from here to there. Okay? So that's U equals 35. And U equals 35. Means when this quadratic equation greater than, when this quadratic equation above, they need it strictly 50 meters or more, means equals to 50. The line y equals 50. That's math. See, people? So we say that it's a 50, and this quadratic, that's the u. Basically, I'll keep it equal. I'll not include this. Let me write down the quadratic. So the u is 35t plus half the acceleration, that's a negative 9.8, okay, times t squared. That's a quadratic. So we need to find out the solution of this quadratic above, greater than, or equal to. طبعا حكيتها غلط, فبالتالي هي above the line y equals 50. Then get the 50 to this side. Then that's a quadratic inequality, and we can solve it easily. Okay, let's see the calculations. I don't have a calculator. So that's a quadratic. So when this quadratic ABC, and then t between those two numbers, t, the first t, see, this is your quadratic equation. The first t is 1.9, the second t is 5.1. This is math, right? So the time between them, so the time interval, this minus this, you will get the duration. Find the total time for more above the ground. That's the, subtract them, then you get the equation. Okay, wait a minute. So it's 5.1 minus 1.9, that's a 3.2. That's math, people, math. Look at the question from mathematical point of view. The total time for this wall, for me, طلعت عليها لقيتها quadratic. So it has to be quadratic equation. Above the ground means 50 meters above the ground, means that's a quadratic equation above the line y equals 50. So as we took in P2, an inequality for quadratic greater than 0, and that's it. We're done. A ball falls vertically from the top of tower, 36 meters high, and the same time as as A begins to fall, another ball is projected vertically upwards. يعني في عندي A هنا، في عندي B هنا. High is going down, high is going up at the same time. Same time means that U equals 0, and for this one there is a U. Upwards vertically, tower velocity 21. So that velocity is 21. Now the acceleration over here is 9.8. The acceleration over there equals negative 9.8. Okay, and remember, this is the total distance. Okay, find the height at which this happens, which is they will hit each other. Meta this is the total height 63. If I consider this height is x, this height is 63 minus x. So we have a distance for each one of them. We have displacement, we have u, we have acceleration, and we have distance. And they will collide at, and there is also a distance, a u, and acceleration a. Okay, now let's see. For both of them, that's at 21 diagram, we wrote it, and we wrote the for ball A, ball B. Then for ball A, the distance is equal to, for example, S1, and I حطيتها X. Okay, and we do substitution. We found out S equals 4.9 T squared. Then we will find S2. Let's find S2, and S1 plus S2 supposed to be 36. That's an equation. That's an equation, so T equals 3. So they will collide at 3 seconds. So we have, my target is to make a relationship between the two variables, unknown variables, S1, S2. That's the time. Then do substitution in any one of those equations, S1 or S2, you will get this. Now, yeah. So let me check the chapter. Let me check the sharing and the chapter inside your book. I hope if you can prepare those questions. See, we have discussed all questions in the book, in the slide. I hope if you can do this chapter exercise 2F, try to do it, please, as much as you can. And I hope if you have any questions, just send me on WhatsApp على الجروب تبعتنا. Now this is chapter review. This comes to the end of this chapter, which is chapter 2, and questions. We will not take vectors. We will skip vectors for now. Back in our next plan, inshallah, we will, let me see the chapters. That's chapter 2. We will go for dynamic. Chapter 4, dynamic for particles moving in a straight line. And then that's the force diagram and so on. Okay. Thank you very much, and see you tomorrow at 1:30.